The purpose of this video is to show how the distributive property works. And the distributive property is how polynomials are multiplied by a constant or a monomial, and that's what we'll talk about here. It can also be extended to larger products too. We won't get into that in this lesson, but it can be. And so if you have a times xy, and there's an implied multiplication here, so we actually will multiply, or sometimes you use the word expand, the a into this sum. The word distribute is also used, which also means to multiply the a into the whatever's in the brackets, basically. So we'll start with a, and this arrow means to multiply the a by the x, so that we would call ax. And then we multiply the a by the y, and we would call that ay. So after you expand or distribute the a into the x plus y sum, you get ax plus ay. And so we're going to take a look at a couple of examples with 2 or 3 parts to each. And the first one says expand using the distributive property. And so we're going to expand this 5 into the brackets and multiply the 5 first of all by the 2x. So 5 times 2x. 5 times 2 is 10. And since there's just a single x here, the product would be 10x. 5 2x's is 10x. 5 times 2 of anything would be 10 of that thing. So we get 10x. And then 5 multiplied by the negative 7 is minus 35. Now you can think of this as 5 times 7 is 35, and since we were subtracting the original 7, we should be subtracting the 35. If you go with just the signs, it works the same way. 5 times, and you can think of this as negative 7, is negative 35. So it's 10x, subtract 35. Subtracting 35 is the same as adding negative 35. That's why that sign thing actually works. In the next example, we're going to distribute the negative 3x into the two terms here. So when I multiply negative 3x by x, I get negative 3x squared. Well, why is it x squared? If you see negative 3x, there's one x here, and there's also one x here. So when I multiply by an x times another x, I'm actually multiplying two x's together, and that's what x squared means. X squared means you have an x times an x. And then, so I multiply the negative 3x by the x to give negative 3x squared, and then negative 3x times negative 4 would be a plus 12x. Negative 3 times negative 4 is 12, so that's why it's plus 12, and I have a single x in that product, so the product has an x in it. Next, we would multiply the 4a into this trinomial here. So there's an exponent of 1 here, and there's an exponent of 2 here. So altogether, there's 2 and another 1. There's 3 a's. And so that's why it would be a cubed. The product would be an a cubed. Now we also multiply the 4 by the 2, so that's 8. And we would write a cubed. That's 8a cubed when we multiply the 4a by this. 4a times minus 5a would be minus 20. 4 times negative 5 is negative 20. And there's an a times another a would be a squared. You add the exponents, so 1 and 1 here adds to 2. And lastly, 4a times positive 3 would just be a plus 12a. In example number 2, it says expand using the distributive property and then simplify. There wasn't an and then simplify in this one because there were no like terms to combine together, but there will be in these two examples. So the first one, we would first expand the 4, or distribute the 4 into the 5x plus 2. So 4 times 5x is 20x, and then 4 times 2 is 8. Both those are positive, so it would be plus 8. Next, we would multiply the 3 into the 2x minus 6. So 3 times 2x would be 6x, and 3 times negative 6 is minus 18. Now there are some like terms here. So notice that this is an x term, and this is an x term, and so 20x and 6x will add to 26x. Similarly, the 8 and the minus 18 are numbers, so they're like terms, and so we would combine those together. And so it's positive 8, subtract 18, which would be minus 10, so we would write subtract or minus 10 after the 26x. Lastly, in B here, we're going to distribute the 3f, into the 2f squared minus f plus 4. So 3f times 2f squared, 3 times 2 is 6, and an f to the first times an f to the second is an f to the third. Remember, we add the exponents, so 1 and 2 add to 3. 3f times a minus f will be 3 times negative 1 is negative 3 in front, and f times an f would be an f squared. There's 2 f's multiplied there. And then 3f times 4 would be a 12f. Now, when there's just a subtraction sign here, it's like there's a negative 1. That wasn't a very good negative 1. Let's try that again. It's like there's a negative 1 right here. And so that negative 1 is going to get multiplied by all the terms here. Now, when you multiply anything by negative 1, it really just changes the sign. You see, the 8f squared is positive inside the brackets. When we multiply that by negative 1, we'll get minus 8f squared. The 6f was a positive term here, so multiplying by negative 1 times 6 is negative 6, so it'll be minus 6f. The negative 5 on the end, or subtracting 5 in the end, negative 5 times negative 1 is a positive 5, so we'll put plus 5 in the very end. And there are some like terms. Now, this 6f cubed is the only f cubed term, so we'll just write 6f cubed. But this f squared term and this f squared term are like terms, and so they would combine to give you negative 11f squared, so negative 3 and negative 8 is negative 11. You can also think of it as negative 3 subtract 8, which is also negative 11. This 12f term and minus 6f term are like terms, so 12f minus 6f is 6f, so that's positive. 12 minus 6 is positive 6, so write plus 6. And the 5 in the end is the only constant. There's no f with that one, so we just write plus 5. And so that is simplified. The simplification is the adding and subtracting like terms together. And that's the end of the video.